spring concept, loaded spring, in which first one is relation between K and L, and second one is cutting off spring, and next see there series combination of springs and parallel combination of springs, and parallel combination A, B, C, three diagrams are there. Okay, after that we will have the numericals. See this is 2023 question and this is 2024 question main. Okay, step by step I am going to explain clearly about it. Please watch full video, you will get clarity about the concept. Hello everyone, I am Kiran Kumar from Nature of Physics. Hope all are reading well for the exams. Today topic is loaded spring and also spring concept and cutting of springs and parallel combination of springs and series combination of springs and also time period, frequency of the loaded spring. Step by step clearly I am going to explain. See student, for this today my work, and before that please do like and subscribe our channel Nature of Physics. So first, considering a spring suspended vertically from the rigid support S and loaded with a mass small m from the mean position O, and the mass is getting oscillation due to the small vertical jerk acting downward direction, so that there is a force is acting downward direction. That force is taken as weight mg. Okay student, and then continuation, there are two forces are there. One is the weight of the body, that is mg acting downward direction, so that the body get displacement downward direction. Y is the displacement from the mean position to extreme position, and restoring force is opposite direction, okay, to the elongation of the spring. See, clearly represented and highlighted student. And continuation, when the block is left from A position, so it is doing simple harmonic motion from the mean position. Here considering two extreme positions A and B, one mean position is O. So once again noticing restoring force and displacement both are in opposite direction, highlighted. K is the spring constant, so that here restoring force is directly proportional to the minus y. Okay, and Fr, which is equal to minus k into y. Minus represent opposite direction. So what are opposite direction student? One is the restoring force acting upward direction and displacement is acting downward direction. See there. And continuation, from this equation I can write from the Newton's second law, that is Fr, which is equal to ma. So replacing that, I am going to get ma, which is equal to minus ky. Okay, so that A, which is equal to minus k divided by m into y. So that from simple harmonic motion SHM, the equation is A is equal to minus omega square y. Comparing the both equations, we will get here omega square, which is equal to k divided by m, and also omega, which is equal to root over k divided by m. Omega is the angular velocity from the simple harmonic motion. Okay student, acceleration is same, negative sign same, y also same, so k by m is balancing with omega square. Okay, from this equation we can use k force constant, k which is equal to m omega square. Frequently we will use this equation. Okay student, and then I'm going to write there time period omega, which is equal to 2 pi by t student. which is equal to root over k divided by m. Okay, and cross multiplication we will get 2 pi root over m divided by k, which is equal to t. Okay, so that time period t, which is equal to 2 pi root over m divided by k. So this is, I can write as equation number 1, time period is write as equation number 2, and next one is frequency is there, mu, which is equal to 1 by 2 pi root over k divided by m. This I can write as equation number 3. Yes student, clearly written time period and frequency equation with respect to capital M, mass of the spring included. Okay, and then here relation between capital K and L. So capital K is the force constant or spring constant, and L is the length, normal length of the material, that is the original length of the spring. Okay student, and F is the force is acting, that is external force, and next one is here restoring force is opposite direction to the external force, and also there is a elongation is x is the elongation, and continuation derivation based on the restoring force directly proportional to the minus x, already we did. This is the vertical direction, why we got here horizontal direction, I got x, so taken x is the displacement, that is elongation. So that restoring force is equal to minus kx, so that minus represent opposite direction, already written here, so that Fr is equal to minus kx student. So from the Young modules, y is equal to stress divided by strain. So from this I am going to get the force equation, both forces will balance, then we will get the relation between the k and L student. See there, so from this writing ya x by L, which is equal to F is the force, is taken as equation number 2, and equation 2 equal to equation number 1, so that kx, which is equal to ya x divided by L. In this equation x is get cancelled, so that I am going to get there k, which is equal to ya divided by L, so that I can take this is equation number 3. From this equation we can write k is inversely proportional to the length of this spring. This is equation number 4. Very clear explanation, relation between the k and L. The length of the spring is L, original length. K is the spring constant or force constant. This spring is cut into two different lengths, L1 and L2. L1 force constant is K1, L2 force constant is K2 respectively. So that we will get the relation between them. So that first writing here, K spring constant is inversely proportional to the length, so that KL, which is equal to constant. Okay, and then continuation equation is K1 L1, which is equal to K2 L2, which is equal to KL. Okay student, from this between the first and last we are going to get the relation, that is K1, which is K1 L1, which is equal to KL. From this equation K1, which is equal to KL divided by L1, and also we can write K1, which is equal to K of L is equal writing L1 plus L2 divided by L. This is written as equation number 1. Okay student, and then continuation step, next one I am going to write for the second relation like this, that is K2 L2, which is equal to KL. so that I can write here K2 which is equal to KL divided by L2, and from this equation we can write K2 which is equal to K of L1 plus L2 divided by 2, that is equation number 2. And one thing you have to notice, the total length L which is equal to L1 plus L2, L1 plus L2. And for example, L1 is equal to L by 2 and also L2 is equal to L by 2, that is half of the length. Okay student, and the value is replacing in the equation 1 and 2, so that K1 which is equal to K into L by 2 plus L by 2 is L divided by this L1 is equal to L by 2, LL is get cancelled, so we will get there K1 which is equal to 2K. Okay, and also continuation K2 which is equal to K into L1 plus L2, that is L by 2, L by 2 is L only, divided by L by 2, LL is get cancelled, here we are going to get K2 also 2K. When the spring cut into two equal length, then the spring constant of individual springs is twice the force constant of initial spring, twice the force constant of initial spring. Okay, and then next I am going to discuss about the series combination and parallel combination of the spring student. Okay, for the series combination of the springs, now K1, K2, two springs which are connected in series combination with a mass m, and their x is the elongation in the spring due to the applied force F. Okay student, so that here I am going to write first derivation for the series combination. This spring is moving elongated x1 and this spring is get elongated is x2, total elongation is x, so that x which is equal to x1 plus x2. From the force equation, F which is equal to K K1 x1 and force F which is equal to K2 x2. So that notice one point here, the force is applied is same only. So from this equation I am going to get x1 which is equal to F divided by K1 and x2 which is equal to F divided by K2. So both are replacing in the above equation. Okay, and also we can replace there F is equal to Kx, F is equal to Kx, so that F by K is equal to X, also replacing. So first one, second one, and also X value is replaced in this equation, so that X is equal to F by K which is equal to F by K1 plus F by K2. Okay student, force is common and cancel, so that 1 by K series combination Ks which is equal to 1 by K1 plus 1 by K2. Okay student, and then continuation step here 1 by Ks, okay, LCM taken, so that Ks which is equal to K1 K2 divided by K1 plus K2. Okay, both the equations I got, equation number 1 and equation number 2, so that these values are replacing in the equation of time period. So time period equation T which is equal to 2 pi root over m divided by Ks. Okay, so the value is replacing now, so that we will get the time period equation T which is equal to 2 pi root over m into K1 K2 K1 plus K2 divided by K1 into K2. See, this is I can write as equation number 3 student. Time period equation I got m omega square. So the value is replacing, so that I am going to get there 1 by ks, which is equal to m omega square, which is equal to 1 by m omega 1 square plus 1 by m omega 2 square. M common and cancel, so that 1 by omega square, which is equal to 1 by omega 1 square plus 1 by omega 2 square. This is series combination. I can write omega s because of omega equation replacing, that is equal to 2 pi by t in the next step. 1 divided by 4 pi square divided by ts square, which is equal to 1 divided by 2 pi by 4 pi square divided by t1 square plus 1 divided by 4 pi square t2 square. Okay student, and 4 pi square common and cancel. I am going to get there, that is ts square, which is equal to t1 square plus t2 square, and ts, which is equal to root over t1 square plus t2 square. This is written as equation number 4. This is a relation between the time period of spring 1 and also spring 2 with respect to series combination ts. Ts is equal root over t1 square plus t2 square. And also continuation steps and parallel combination I am going to explain. In the parallel combination, first one is force is resolved into two components. So this is the force is taken as F1 force, this is the force is taken as F2 force. So that F is equal to F1 plus F2, and also equations replacing there, F is equal to Kx, F1 is equal to K1x, F2 is equal to K2x. All the values are replacing, so that here x is remains constant student. So that the resultant equation is now F replacing with Kx, which is equal to K1x plus K2x student. X is common and cancel, so that I am getting K, which is equal to K1 plus K2. So this is parallel combination. Now I can write this is equation number 1. Okay student, so parallel combination I got Kp is equal K1 plus K2, and series combination Ks I got K1 K2 divided by K1 plus K2. Okay, and replacing in the time period equation, so that the time period equation is t, which is equal to 2 pi root over m divided by kp. So p value replacing now, so t, which is equal to 2 pi root over m divided by k1 plus k2. This I can write as equation number 2 student. Okay, see that, notice here this below derivation is related to the series combination. Okay na, series combination. This is continuation step I did here. Okay student, and then continuation here, three diagrams are represented for the parallel combination. This is the first diagram, this is the vertical diagram, so this is the horizontal diagram. So first one also horizontal diagram. In the first one, the spring F1 force, F2 force is here. Also we can take F1 force and F2 force, downward direction force is acting F, but anyhow result is same only. In the third diagram we will get small confusion. This is either series combination or parallel combination. One thing you have to notice, this should be parallel combination only, because of in the parallel combination force is distributed and displacement is remains constant, because of K1 spring get elongated x and K2 spring get compressed x. So there is no change in the length of the spring of first spring and also second spring. Length is remains constant, so that L is equal to constant one spring elongated and another spring get compressed. That's why this combination is should be parallel combination of this spring, so that first spring and second spring both are connecting to the rigid support, and between them there is a block of mass m is acting between them. Okay student, and then continuation next to derivation for this relation with respect to time period, that is, wait a second. So using equation number 1, from equation number 1 we can write the equation is k which is kp which is equal to k1 plus k2 student, and k which is equal to m omega square. The values are replacing, so that m omega p square which is equal to m omega 1 square plus m omega 2 square, m common and cancel, so that continuation step omega p whole square which is equal to omega 1 square plus omega 2 square, but omega which is equal to 2 pi by t is replacing student. Then I'm going to get there, that is 4 pi square divided by tp square is equal 4 pi square divided by t1 square plus 4 pi square divided by t2 square, so that 4 pi square common and cancel, so that 1 by tp square which is equal to 1 by t1 square plus 1 by t2 square. Okay, and take LCM, so that 1 by tp square which is equal to t2 square plus t1 square divided by t1 square into t2 square, and continuation step here, that is tp square which is equal to t1 square into t2 square divided by t1 plus t2. So final equation is tp which is equal to t1 into t2 divided by root over t1 plus t2 square is there. Sorry for the mistake. This according to the question here, the time period of the simple harmonic motion of a given diagram t is equal pi into root over alpha m divided by 5k, where alpha is asking student. So this is the series combination and parallel combination of the springs are there. So first one, two springs are in parallel combination, result with k is series combination, and result with left side k represent the left side spring represent the parallel combination. So first one, parallel combination formula, so that kp which is equal to k1 plus k2 student. Okay, the values are replacing now. Kp which is equal to equal force constant is given, that is k plus k. So kp which is equal to 2k. So now the kp and this k in the series combination. For series combination formula, ks which is equal to k1 k2 divided by k1 plus k2. In this equation, ks which is equal to k1 is written as 2k and k2 is written as this k divided by 2k plus k, so that ks which is equal to 2k square divided by 3k. 1k is get cancel, so that I am getting here ks which is equal to 2k divided by 3 student. First two springs are in parallel combination, result is series combination with third spring. Okay, is completed. Now the resultant is with fourth spring is in the parallel combination. See there, parallel combination, so that parallel combination formula kp already taken, that's why kp dash is writing like this, k plus ks student, so that k dash p which is equal to k plus ks value is 2k divided by 3, so that k dash p which is equal to 5k divided by 3. So the time period equation t which is equal to 2 pi root over m divided by k, student. Here I am writing kp dash. So value is replacing there, t which is equal to 2 pi root over m divided by 5k divided by 3, student. So that t which is equal to 2 pi root over 3m divided by 5k. So 2 is multiplied into the square root, so that t which is equal to pi into root over 2 to the 4 and 4 into 3 is the 12m divided by 5k. 12m divided by 5k is the answer for the given question, student. So that according to this question here, alpha value which is equal to 12 is the answer. Hope you understood. Another problem. In this problem here, there is a block of 490 grams that is suspended or connected between the two springs, that is K1 and K2. Both have the same force constant and fixed to the two rigid supports. Okay, student. So in this, force constant is equal to Newton per meter is given and displacement also given, x, student. So like this, there is a displacement is x. So one spring get elongated, another spring get compressed, student. So in this question, one thing you have to notice, already I gave you in the concept, look like a series combination, but concept wise it is a parallel combination because of length is remains constant, L is equal remains constant, total length of the springs. So this should be parallel combination. So parallel combination formula is, that is T which is first parallel combination formula writing. So parallel combination force constant Kp which is equal to K1 plus K2, student. So Kp which is equal to 2 force constant are same given, that is K plus K is 2K. So and continuation in this step, and next one here value also replacing K value, that is Kp which is equal to 2 into 2 Newton per meter. I got Kp which is equal to 4 Newton per meter. Okay, student. And what is asking in the question? See, in the question, number of oscillations in 14 seconds is asking. What is asking there? Number of oscillations in 14 seconds. So for this, notice small t which is equal to capital N into capital T. So capital N represent, what is that? Number of oscillations. See, student, and from this equation I can write N which is equal to small t divided by capital T. So in this, small t is given by 14 pi seconds and capital T we have to find out. So for capital T, that is T which is equal to 2 pi root over m divided by Kp. Kp value is replacing now T which is equal to 2 pi root over mass is equal to, here mass is equal given in the grams converted into kg. Okay, student. So that once again please, here I can write mass is equal to, m is equal to 1490 grams given, that is converted into kg. 1 gram is equal 10 to the power of minus 3 kg. So that small m which is equal to 0.49 student. Okay, so that 0.49 writing divided by Kp value I got 4. So that time period t which is equal to 2 pi root over 0.7 into 0.7 divided by 2 into 2. Okay, student. And continuation step here, t which is equal to 2 pi into 0.7 divided by 2 to get cancel. So finally time t which is equal to, I got 0.7 into pi seconds. Okay, student. This is I can write as equation number 1. This is I can write as equation number 2. This is I can write as equation number 3. So now equation number 2 and 3 in equation number 1, student. So the result 14 pi, which is equal to, small t is replacing, that is 14 pi seconds, which is equal to n into capital T value I got 0.7 into pi. Pi is get cancelled, so that I got n is equal 14 divided by 0.7, so that n, which is equal to 20 oscillations, is the answer for the given question. Please do like and subscribe our channel Nature of Physics.